So this was the problem, right? You have a set of pulleys and belt. A rotates counterclockwise. Rotation of A with belt turns the pulley C. C and D are attached together, so they have the same omega, alpha, everything. And then as D rotates, this pulley is going to rotate B. All the dimensions are given. It says when time is 0 at the beginning of the analysis, we have omega A here. So this is the initial situation. There is an alpha of 2 radian per square second for A. So technically, and it is counterclockwise, same direction. So technically, we start analyzing this when omega is 5. And this keeps increasing its omega because of alpha. At the end, you want to see how much is omegas and everything, but where is the end? The end is when B rotates 6 revolution. So some information is given about, A, and the displacement, angular displacement is given about B. Last time, we derived equation that relates omega A to omega B, alpha A to alpha B, and all of that. And hopefully I have not deleted that thing. Okay, that was here. So let's share the screen. So just to refresh your memory, we related omega A and C move together through this belt. So we related omega A to omega C. C and D go together, and then we related D to B, right? Same way. And that was the relation. Now, from A to C, C to D, and D to B, we could simply relate omega A and omega B with this relation. And we got this number. We substitute the values, we got this number. So whatever omega A is, omega B is going to be 0.675 of that. And if you integrate this over time, you're going to get the same relation for delta theta. And if you differentiate with respect to time, you're going to get the same relation for alpha. Up to here is clear, right? Okay, now, practically, we have pulley B with delta theta, and we have pulley A. And let me see, if this goes this way, this goes the same way. Okay. We have pulley A when omega 0 and alpha is given. We know that we can relate theta, omega, and alpha, but this has to be for the same rigid body, right? Either I will transfer this information to B through this relation, or transfer this piece of information to A to have delta theta omega alpha for the same. Which one you prefer? I'm going to ask Callie, who has the majority of the class. You want to analyze B or A?
Let's analyze B.
B, okay. If you want to analyze B, for B, delta theta B is 6 revolution, which is going to be 6 times 2 pi in terms of radian, 12 pi. I need to find omega B at the beginning and alpha B, and how I can do that. Remember, this information is given for A, and I can relate A to B. So technically, if omega 0A or omega A0, if omega 0 A0 is given, which was how much? Let me see. 5 radian per second. This relation between A and B exists at any time, including the initial moment, right? So if that's the case, I can get from here omega B0, the initial omega B is going to be 0.675 omega A. And if you do that, 0.675 times 5 gives you omega B, the initial value, 3.375 radian per second. Someone wrote inch per second. Remember, these are angular, has to be radian. Now, if I want to find alpha B, again, alpha B is going to be 0.675 alpha A. The same ratio, right? Because they are technically attached or constrained to move together. So you're going to get 0.675 times 2, 1.35 radian per second. So now let's look at B again. Let's say this is the pulley B. It has a delta theta of 12 pi. It has omega 0 of 3.375, and it has alpha of 1.35, right? The problem asks us to find the angular velocity of B after 6 revolutions. So we have theta and omega and alpha in the problem. Which equation comes to your mind to use? If you go back to your slides, you're going to see omega d omega equals alpha d theta. And remember, alpha C, alpha A here, all the way on the top, alpha A is constant, right? So if it's constant, therefore, alpha B is also constant. And then this equation is going to be half omega B squared minus half omega B 0 squared is equal to 2 alpha B delta theta B, right? I integrated this because alpha is constant. It gives you this equation. Therefore, omega B squared, and sorry, this shouldn't be 2. This should be alpha delta C. And then it's going to be 2 alpha B delta theta B plus omega B 0 squared. If you substitute the numbers, 2 times 1.35 times 12 pi plus 3.375 square this is going to be 113.18, and then omega b is going to be a square root of that, which is 10.639 radian per second. So that is how you do it. I saw the few of you guys solve this, got kind of confused about how you relate. Okay, does it make sense? So remember, when you have chain of rotating objects, you could have belt and pulleys like this. You could have chain and a sprocket like your, bike, or you can have a set of gears, right? There's always the change of omegas. If this is, imagine you have two gears. I'm not going to draw the teeth, right? Let's say this is like gear A and this is gear B. It could be disc, it could be gear. The point is, I don't know if you can see my hands. When you have gears, they, at the contact point, because of the teeth, they move together. So technically, if we consider this point M, velocity of M, considering it is a part of A, and velocity of M, considering it is a part of B, should they be different? Someone say something. I don't know if you can see my fingers. If you have a set of gears, right? When the two teeth, it's just two teeth touching each other, they move together with the same velocity. If you have two rolling objects roll on each other, at the contact point, if there's no sliding, they have the same velocity. So it should be the same, right? If that's the case, Vm for A, Vm is going to be, let's say this goes this way, omega A, and this has to go other way, omega B. And let's say this is RA and this is RB. Vm rotating about fixed point on the circular path, it's simply RA omega A. For B, Vm is RB omega B. And these two have to be the same. Therefore, again, you're going to get RA omega A equals RB omega B, or omega B over omega A, RA over RB. Same relation we got for the pulleys. The only difference, if you have a set of pulley, if it goes this way, omegas are in the same direction. For discs or for gears, omegas are opposite direction. Make sense? So practically, when you change the speed ratio in your bike, and I can't draw that very perfectly, but let's say like this is a bike. Okay. And then you have a set of sprockets here, and you have a set here, right? If you go from smallest gear to biggest here, for one rotation of this is going to have so many rotations, right? So if you go from this guy to that guy, which is kind of same, the omegas are similar. If you go from small up front to big in the back, you get bigger omega here than here, right? That's how you adjust, your pedaling speed, and based on that, you can provide more or less power. But it's the same thing. RA omega A is RB omega B. And if you keep going with other gears or pulleys, this is going to continue, right? That is how you can calculate. And remember, similar to this problem, when you solve a problem like this, you transfer all information on one rigid body, because these expressions we use here, omega D, omega R D alpha, or even like omega is omega 0 plus alpha T, or theta is theta 0 plus omega 0 T plus alpha T squared by 2. These are all for the same rigid body. You cannot pick information from A and mix them with information from B, because they're different rigid bodies. Does that make sense? Okay. I think we're almost done with the lecture. Yeah, that was it. Thank you very much, guys. I hope you had a good midterm. I try to grade them as soon as possible. Hopefully, maybe for Wednesday. If not, by the Friday, I try to make it, ready for you guys to see the feedback. On Wednesday, we continue chapter 16. And if you have any question about any part of the course, please let me know. I try to make a quick, appointment to see you guys if needed as soon as possible. Okay. Thank you and enjoy the rest of your day. Bye.